Welcome to Fuzzybutts and Friends. Well, as much as it drives Fuzzybutts all over this place, absolutely crazy when they hear me say it, I am the host of this show, your big dog, Luke Robinson, and I'm back again with you this week. And look over to my left, who's back with us again. This week, it's Ginger Morgan. She's the co-host and co-producer, and she's also the executive director of the Puppy Up Foundation. Ginger, how are you this time?
I am doing well. It's been a busy week for me here in Memphis, and I'm looking forward. The last time our guest was on, I was sick and I couldn't participate. So I'm really looking forward to the show today.
I am very glad you have the opportunity to meet the honorable, the wonderful, the powerful Dr. Jaime Modiano. We had a great conversation, and I realized, Ginger, when I was introducing you, look who's back again with us this time, and I realized, wait, you weren't on episode 1 with Dr. Modiano, so it's like it's a new experience for you.
Yeah, exactly, because I had laryngitis, I believe.
That's right. That's right. Because you talk all the time. It's hard to get a word in edgewise here on our podcast. Yep. So it's a good thing that you learned from that now, and you're more judicious in your speech. So, all right, we're just kidding around. First off, I need to apologize to our audience. In addition to moving to Texas, my laptop crashed and I don't have my iPad with me. And the only device I have is my iPad, Ginger. And we tried to do this podcast on the iPad so that we didn't miss any. We had to reschedule so many episodes. It's been a nightmare scenario. But for some reason, the iPad, Apple doesn't work with Zoom. That doesn't work with Gmail or Google. It's like the three tech giants. They just don't like each other, and it didn't work, and we couldn't figure out the problem. So my apologies. My laptop should be fixed. It won't take a charge, so they have to order the new part that they're going to solder on.
Well, you know, the other thing that the laptop that you're borrowing doesn't like is you going back and forth.
I gesticulate. I'm an active guy. My synapses are always firing, and physically too. So I am trying to contain myself. So my apologies again if I move around or the audio quality is not that great. I should have my laptop fixed and back up here within a week. So again, my apologies. And on that note, Ginger, I'm excited to have back again on the show. We had a great discussion last time. You weren't a part of it. You missed it all. Did you have a chance to watch it so you could educate yourself about our terrific guest this time? Or
I did, but that was last year. So
it was last year, and I want to have him on every year because he's always got something neat and exciting and interesting going on with his laboratory up at the University of Minnesota. On that note, I'm glad to have back on the show Dr. Jaime Modiano, a beautiful scientist, veterinarian, and creator up in the Great Lakes. What is it? The state of the Great Lakes, or the land of many?
The land of 1,000 lakes.
The land of 1,000.
I'm sorry, 10,000. 10,000.
10,000.
Yeah.
10,000.
And if you want to be correct, it's 11,347.
That's right. Now they're not really lakes though. They're more like playas. They're like small lakes, correct?
Well, we have everything from Lake Superior up north, which is the largest freshwater body, to tiny little wetlands that dot the landscape. A person we knew described Minnesota as the land of 10,000 islands. So, it depends on your perspective as to whether you're a water file or a land file. But we do have a lot of water to play in.
You do. It's fascinating. I've been up there a couple of times. I want to come. I have not been up there to tour your lab. Last time we talked, I said I would do that. It was a crazy year last year, but it's still on my list of things to do. But what's interesting is that you have the beautiful boundary waters up there, which is, like you said, it's really like you take a canoe and you get in your canoe and you paddle for a while, and then you hit an island, and then you carry your canoe to the other end. It's gorgeous up there. Well, thank you for taking time out of your busy schedule, Jaime, to meet with us and again. And just for the audience, I think we've grown in size and in our audience base since we last chatted. So for the new people who are seeing you or meeting you for the first time, Jaime, first off, we'd like to start off the show with Fuzzybutts. It's about Fuzzybutts. So what Fuzzybutts do you have in your life?
Yeah, well, first, let me say thank you for having me. And I'm very grateful that you're having me back. You must be scraping the bottom of the barrel now.
Oh, not at all.
But let me tell you about my fuzzy butts. So we have two fuzzy butts, Alcy and Mora. Alcy is a 6-year-old German Shepherd, and she comes from Western sort of herding show lines, and Mora is 2.5-year-old German Shepherd, and she comes from East European lines. And Alcy is just the most beautiful girl ever, and that's all she wants to be. And Mora is starting on the path to be an agility champion. So they are and they're absolutely best friends. So we're very excited, and they're best dogs ever.
So are you?
So
I
that's
love
our
German
Fuzzy Butts.
Shepherds.
They're both German Shepherds, yeah.
I'm a notoriously Pyrenees guy, and it's by accident and circumstance. It's not something my ex-girlfriend gave me my first Pyrenees, and I think she did that because I'm a difficult guy to get along with. I'm stubborn, and I think she was like, "Here, take this. I'm going to give you the hardest darn dog that just doesn't listen to anybody." But I love Pyrenees, and obviously the breed, it makes sense. So I'm on my 5th one. Is that true of you and German Shepherds?
Well, we had one German Shepherd before Alcy and Mora. Her name was Ketsi, and she stole our hearts. She was just both of our heart dog. Michelle actually was indoctrinated into German Shepherds as a compromise because she was a Gordon setter person, and I was a rescue person. I'd had Mutzkers before, and so when we sat down and we decided what we could both agree on, there was a lot of debate, and we agreed that German Shepherds were probably it. And we've been just incredibly happy since when we got Ketsi, I flew out to California and picked her up and brought her back, and it was a whole adventure. But she walked into her house just like a 11-week-old puppy and looked around, and she just said, "Oh, it's all mine." And she was the princess, and it's been a journey ever since. So we're very happy with our girls. They really are just such wonderful girls. They fill our lives with joy. So
Excellent.
we
Well,
definitely know what
good
it's
that you
like.
have the love for companion animals, love for fuzzy butts. I don't trust veterinarians that they don't have dogs. That's sort of that's the hard rule of life that I live by. But the good thing is, I think, Ginger, everybody we've had on our show is just that's part of their origin story. Is they had a dog that changed. It was sort of the inflection
Correct.
point in their life early on, and it changed them, and they ultimately went on they dream about becoming a veterinarian like so many kids do, but they had that one dog that inspired them. So in that vein, Jaime, we like to talk about what we call origin stories. Everybody's a superhero these days. That's what they say. I know you are. You're doing some super heroic things up there at Modiano Lab up in Minnesota, and that's important. So as briefly as you can, or as long as you want to talk about how did you get your start, up until where you're at right now.
Sure. So I'll be brief. I'll start by saying that Emma Vogue and The Incredibles said no capes, so I do not wear a cape. We don't want to get caught in a plane engine. So as a kid, I was very curious. I loved nature. I think I was just born with that gene of trying to understand nature. I thought I wanted to be a zoologist. My mother thought it was very cute. My dad, not so much. When I didn't change my mind as I headed off to college, they were both a little freaked out. I did my undergrad at A&M, which was really an amazing place in terms of resources and opportunities. A&M offered a lot of opportunities for motivated students, and so I found myself working with two evolutionary geneticists, Dr. John Wolfe, who studied fishes, and he studied he studied freshwater fish from the context of the evolution of cyprinids. And then Dr. James Womack, who was a member of the National Academy of Science and studied cattle genetics. And another really big influence was Dr. Baldwin, who was my biochemistry professor, who basically told me that I would be wasting my time if I became a clinician, because I was really born to be a scientist. And so I think the three of them sort of molded my idea to go and do both. So I was accepted into the combined degree program at Penn, and I did the VMD PhD program. And there I had the honor and the privilege to train with Peter Knoll, who's the father of modern cancer genetics. Peter Knoll was everything that I would ever want to be. And he famously told me, well, he told me a lot of things, but one of the things he told me was that cancer genetics was something of the past. I think he didn't actually foresee the future all that well, but he said you should become an immunologist because that's what's going to be important and exciting and will keep you employed. And so he was correct there, because immunology, as you know, has exploded. And I do love the idea that I am trained as an immunologist and I'm a card-carrying immunologist. And when people talk about immunotherapy, I can actually understand it because I grew up in that field. Dr. Knoll also told me, Dr. Knoll discovered the Philadelphia chromosome, which was the first genetic abnormality associated with a cancer. And it's a translocation between two chromosomes that's seen in human chronic myelogenous leukemias. And so he told me that as a veterinarian, I should go discover the same thing in dogs. And I thought he was kind of a, crazy old crank at the time. But then a few years later, while Dr. Knoll was still alive, Matthew Breen and I did discover the Philadelphia chromosome in canine myelogenous leukemia, which Matthew affectionately called the Raleigh chromosome, since he was at NC State at the time. And he was the guy who was looking at it under the microscope. So, that it was a great experience to train with Dr. Knoll. I did a residency at Colorado State University. Best time of my life, because that's where I met my wife. We've been together ever since, so we're going on 34 years.
Congratulations.
Yeah, did a postdoc at the National Jewish with Erwin Gelfand, another great role model. Erwin, one of the first people to ever do a bone marrow transplant, first one to do it in kids. So, continued my training in immunology, spent 4 years in faculty at Texas A&M, where my lovely wife decided that my lab should focus more on dog cancer because I was a veterinarian and she was interested in it. And so it's a long story, but this is what we did. Moved to the University of Colorado, where I spent a decade at the medical school in the Department of Immunology. And I was affectionately known as the crazy dog guy. Everybody loved the fact that I was at the medical school studying canine cancer and canine immunology. And then in 2006, the University of Minnesota came calling, and it was a great opportunity for both Michelle and I. So we moved to the Twin Cities and have been here for 17 years now, and just loving every minute of it.
It's interesting that Dr. Knoll said that about cancer genetics, because I think we've learned that cancer genetics is actually very, very complex, and we still just don't have, there's still so much to learn, right?
It is the bomb for sure. And in his day, so when I was in the lab back in the 80s, we were still looking at tumor samples and blood samples under the microscope and quantifying everything by hand. And we knew about DNA, but I don't think that anybody really expected at the time that we were going to be able to sequence genomes for a couple of $100 and be able to do this in mass, right? The idea was that cancer genetics had run its course and we had found the things that were important, and now we really had to focus on how to fight cancer with the immune system. And this was even before Dr. Rosenberg started this is before we actually had numbered interleukins. So the interleukins that we knew at the time were acronyms based on what they did. And so T cell growth factor became an interleukin 2, and Dr. Rosenberg started the trials in melanoma in the late 80s. And there was so much we didn't know at the time, and it was a really exciting time to be in immunology because it was all black boxes, and you could go and pick your black box and make a career. But you're right, cancer genetics now is the thing, right? And there's so many companies and so many industries, and the National Cancer Institute in the US and across every country really focusing on genetics for precision medicine. So it's been a very, very exciting time.
Yeah, I don't know if this is true, but it's sort of an interesting thought. Immunology, it would seem like the advancement of our understanding of immunology I'm curious if that's what gave rise to our understanding of the power of epigenetics, right? It's that genetics is not, it's not a static quantity at all, especially as it pertains to cancer. We know about antigenic drift and shift, and we, well, certainly that applies to cancer, especially as what's, if it starts out of a cancer of a particular cell type or tissue type, it then metastasizes and it becomes an entirely different beast. So is it correct or to say somewhat that our advancement in our understanding of immunology helped us understand epigenetics? Is that correct?
Can we pause for a second?
Sure.
I'm sorry. I need to go take care of. Can you hear the button? I'll be right back.
Sure. Okay. Absolutely. And we're back. My apologies. Dr. Modiano had to go to attend to his shepherd. Speaking of, do they always demand a lot of your attention? Always call them.
Yeah, having German Shepherds means that the alarm is always on and any noise requires investigation. But, you know.
But it doesn't help that they're girls too. I think somehow I think girl dogs are more troublesome than boy dogs, but that's probably a conversation for a different time.
Oh, they are not trouble at all. They just you know, they just like to alert us that there's something happening, and most of the time they're you know, I guess fortunately I would say that it's always been false alarms, but you know, we'd still rather have them alert us if there's something going on. So my sincere apologies. This is one of the advantages and disadvantages of remote work, right? When you can actually be sitting at home doing this, and your German Shepherds demand your immediate attention because there was an insect that flew past the door. So
Exactly.
What's in friends. So we certainly account for Fuzzybutts. That's what the show is all about. And as much as we love them, they can be a little bit distracting and get in the way of business. But
yeah. Let me get back to your question, which I think
sir.
was a really brilliant and insightful question. The question that you asked me was, did learning about how the immune system works help us understand how cancers evolve? And specifically, your question was about epigenetics and the fact that the genome is relatively stable, certainly not in a cancer cell, but the epigenome changes dramatically. And I think that the first hints at that did indeed come from the immune system, where cells can change their programs practically on the fly, right? Very, very quickly. And so even though their genome is stable, and even though B cells and T cells rearrange your genome to make the receptors that recognize antigen, there's a lot of other things that happen epigenetically. And I think that the two fields are intimately intertwined. And now we're seeing the integration of you know, metabolism and foundational biochemistry into this area, which means that you certainly can't be an expert at everything, but it becomes much more exciting because we see the potential of things that are going on. I was just at the annual meeting of the American Association for Cancer Research in San Diego this week. Just came back on Wednesday. And there's so much really cool stuff going on. You might have heard about PET-CT before, where they do positron emission and they can they can combine PET with CT to actually look at the cellular metabolism and the anatomical localization. And now they can actually do the same thing with MRI without using radio tracers. So you can actually study cellular metabolism, image a patient, and integrate a lot of really cool things. So when you look at tumors, you can actually start inferring whether the metabolic activity is coming from the tumor or from the immune system or from the interaction of the two. So it's a really exciting time to be alive, and it's never an exciting time to be a cancer patient, but I think we have a lot more answers now for our patients than we did, you know, even 5 years ago. I think the progress that we're making is just astounding, and there's just so much excitement going on.
And it's only going to get more and more exciting as technology continues to accelerate exponentially. And I want to get to that. There's a lot of things I want to talk about. You're working on an artificial intelligence study, a project that I'm keenly interested in for both intellectually and my curiosity, and also about potentially doing a study with the Puppy Up Foundation and perhaps with Modiano Lab. But before we get to that, interestingly enough, talking about cancer genetics, I noticed one of your scientists on your team has an interest in or background in CRISPR. Is Modiano Lab looking at how to use CRISPR gene editing at all with cancer therapeutics?
Um, it, it's been on our radar. We have used CRISPR as a research tool. We work very closely with collaborators at the University of Minnesota Stem Cell Institute and the Masonic Cancer Center who are actually using CRISPR to adapt to therapeutic modalities. So it's not something that we are specifically working on, but some of our collaborators are working on that. We certainly have used CRISPR as a research tool to try to understand how individual genes contribute to not only the pathogenesis of cancer, but also to tumor response. So we have a paper in the works that should be submitted for publication soon, where there's a drug that we developed that's called EBAT. And I think we might have talked about EBAT the last time we were on. It's a bispecific targeted toxin that not only kills tumor cells, but also reorganizes or rearranges the environment that they live in. And it basically creates an environment that is inhospitable for cancer cells to grow on. So even though the cancer cells might be alive, they can't really thrive. And so the body gets an upper hand and can win the battle. So we use CRISPR to engineer some cancer cells to be impervious to EBAT so that the tumor cells could survive in an environment, but the rest of the cells that contribute to formation of the tumor could not. And it's really given us some terrific insights as to what happens when we have EBAT in a tumor that EBAT can't kill, but it can kill the cells around it, and showing the other side of efficacy. So that's been kind of an exciting project.
Well, remind me, what type of cancer cells, tumor cells are we talking about?
So the tumor cells themselves, so the tumor originates from a cell that undergoes malignant transformation, right? And there's a certain complement of mutations or epigenetic changes that need to happen for a cell to acquire that malignant potential. But the tumors don't exist in isolation. They, we can grow them in isolation in a laboratory in a dish, but in the body they exist as part of a tissue. They actually form a new tissue that we now call a tumor. So, we have livers and guts and lungs. Well, the tumors themselves are essentially an organized tissue. And while they look abnormal to us, they create a tissue that is favorable for them. And the tissue includes not only the malignant tumor cells, but all of the cells that need to support them. So fibroblasts and blood vessels and inflammatory cells and fat cells because they need energy, and muscle cells. So the tumor cells actually either find a home that is suitable for them to grow in, or they educate the cells around them to create this home. And our idea is that when you have a tumor that has an incredibly rapid capacity to adapt to drugs or changes, when you attack the malignant tumor cell with something that you think is very vulnerable to, you can have 1 million tumor cells and you can kill 999,999 of them, but the one that lives is going to repopulate the tumor, right? And it's going to be resistant to your therapy. So our approach has been to not necessarily to not kill the tumor, but to actually go in and burn down the house in the neighborhood. So if you remove the place where the tumor cells can live, then those cells are now more vulnerable. They're exposed to the immune defenses of the body, and the body has a chance to essentially come and clean them up, or even tolerate them because they're not able to do harm by not being able to thrive. So that's been sort of our approach, is that if we can detect the earliest stages of tumor formation, or we can identify vulnerabilities in the microenvironment, we can attack the home before they build it, literally blow up the cement truck that's coming down the road to build the house in the neighborhood, or attack the microenvironment and destroy the house they live in. And so that's really been foundational to our test and intervene strategy that we've deployed recently, which we're very excited about.
It's so exciting, Dr. Modiano. It really is. It's fascinating. I mean, just that that phrase right there, how you said it specifically, Ginger. I'm not sure if you picked up on it, but the tumor cells educate the other cells around them to basically create that microenvironment. So for the audience, and I think people that don't think about about cancer as much as I do, it's fascinating that cancer cells, tumor cells, are that sophisticated or that complex, and that you're right. They need a support system. They need infrastructure to be able to grow and to populate the area. So what stages of clinical trial is that in clinical trials right now?
It is. So we have a study that's been going on now for about 8 years that's called Shine On, and that is our flagship project. We have several other projects in the pipeline. And so Shine On was originally conceived based on a request or a challenge from the Golden Retriever Foundation, where they came to us and they said, we've been supporting you for a long time and we've learned a lot about hemangiosarcoma, but it's still killing our dogs and we need you to do something transformational. We challenge you to do something transformational. And at the time, it just so happened that coincidentally, two areas of research in our lab had converged. We didn't plan it that way. We just, as a scientist, you have to be open to serendipity, right? And just sometimes you find yourself in the right place at the right time. So many, many years ago, we had developed a test that we thought could detect hemangiosarcoma cells in the circulation. And that test had never been deployed because even though the test itself was solid, it did not provide the veterinarian or the owner with enough timely information that would change the course of treatment or outcome. So a lot of times what happens is there's a test that you can run, and the test is really good. But if you don't have an action to follow that test, then the test is kind of worthless, right? And so I was fortunate enough at the time to partner with a company which was amazing. They really are at the forefront of veterinary diagnostics. And so I learned a lot from them about the science and the ethics of diagnostic test development. So it's not only about making a test, it's about making sure that the test is going to actually help your patients. So we had that test sitting on the shelf. And when I moved to Minnesota, another really interesting story about a absolutely brilliant student, one of the smartest women that I've ever met, who wandered around the cancer center and met my colleague, Dr. Dan Valera, and essentially brought EBAT from his lab to our lab because she thought it would be cool. And this is when you get really smart students who are highly motivated and they make decisions on their own without asking their mentors. So that drug became what we now know as EBAT. And right at about that time, we were learning about EBAT's role in changing the microenvironment. So the idea was, if we have a test that could potentially find hemangiosarcoma at the earliest time, and we've learned since that the test actually measures not the presence of hemangiosarcoma cells, although maybe it can, but it actually measures this, what we call the cancer permissive microenvironment. So the changes systemically that allow the cancer to thrive, or that tell us that a tumor is building or remodeling its home. So we had a test that could tell us that, and now we had a drug that could actually intervene. So we started with developing the test in the context of whether it could tell us not only that hemangiosarcoma was present, but that there was a risk for a dog to develop the test, and then an intervention. So we completed the first part was to do a training set for artificial intelligence, machine learning. Our approach was to actually not cherry pick one machine learning algorithm. We actually did 12. And the reason we did 12 is they were scattered into 4 different families. And we said, if we use one artificial intelligence method and it gives us an answer, but we use a different artificial intelligence method and it gives us another answer, then we don't really know what's right. But if the two give us the same answer, then we know we're onto something, right? And if we add a third one and a fourth one and a fifth one and a 12th one, and they all pretty much give us the same answer, then we know that it's not just a quirk in the artificial intelligence. We know that there's patterns there that we can recognize through multiple methods. So we were able to convince ourselves that that the training set was creating a pattern that could be recognized by these algorithms. So then we moved on to the question of whether we could do risk assessment. So we enrolled 200 dogs. There was 100 Goldens, 50 boxers, and 50 Portuguese water dogs. The breed selection, of course, had much to do with a perceived idea that these breeds were at high risk for hemangiosarcoma, but also because of who paid the bills. And then we enrolled dogs that were 6 years old or older and were by all criteria healthy. And we ran the test and we assigned the dogs into a high risk or a low risk group. And then we followed their dogs pretty much for their lifetime. So we have data from 200 dogs that we followed for their lifetime. And basically what I can tell you is that if our algorithms assign dogs to a low risk category, then the probability that that dog will develop cancer over the next 15 to 18 months is pretty low, about 5% or less. But if our algorithm assigns a dog to the high risk category, there's a probability that the dog already has a pre-existing cancer, but there's a 30% probability that that dog will develop cancer over the next year and a half. So, you know, it's not 100%, but it's a significant difference, right? From less than 5 to 30.
Yes.
It's about an 8-fold risk. So there are some nuances to, you know, what are we measuring? We're measuring these cells in the circulation that we believe are contributing to remodeling the tumor. And there are some nuances. So we in our training, we included our healthy population was the dogs that were at least risk of developing cancer, but were skeletally mature. So there's an age component, there's a breed component, there's a sex component. And so we've been trying to deconvolute all of those things. And we're still working on the data, but we are coming to the conclusion that despite my hope otherwise, that a dog is a dog is a dog, there might be some really important breed differences. And some of them might be expected and some of them quite unexpected. So we're still working on that. I don't want to say anything prematurely that I might have to take back later, other than to say that we do see some interesting breed differences. But the other really cool thing is that we then, once we had the data, we said, can we actually fulfill the goal of putting in an intervention that would reduce risk? So what I can tell you is that we have put 8 dogs in the prevention trial. The dogs were at high risk of developing cancer. And so the good news is none of those dogs has developed cancer. One dog's only about a month out, so who knows? Another dog's about 8 months out, so still early. Another dog unfortunately died of heart failure. So it was a boxer that had congenital heart condition. She passed away when she was 10, and there was no evidence of any presence of cancer, although she had tested repeatedly at high risk. And the other 5 dogs, one of them died about 3 3/4 years after our intervention. She was also a boxer, and she lived to be almost 14. So, you know, and died without cancer. So that's a win. And the other dogs are all alive, going on past 2 years. So, but by our criteria, the first thing is that we would assume that a third of 8 dogs might have developed cancer over the course of 2 years. We have 0. It's very, very small numbers, so we're still within the probability of not having observed the events that could have happened. So we can't call it a win yet, but we're excited. The other limitation is that we don't have a placebo control, right? We haven't brought in owners whose dogs are at high risk and told them we're gonna just give your dog a, you know, saline injection and see what happens. The ethics of doing that are kind of squirrely. So
Yeah.
So we do not have a placebo control to tell us that there's something that we're doing in terms of how we educate the clients or how they treat their dogs, or something that has nothing to do with our therapy. But it's enough of a signal to get us excited that there's something going on. And you know, there's some really exciting things about EBAT. As you might know, it is so for full disclosure, it is licensed to a company, and the company's taking it through FDA. And
What's the name of the company?
The company is called Anavive Life Sciences. They're in LA, and the University of Minnesota has a license, and so there will be, you know, royalties that come back to the university if that's approved. But we see EBAT really sort of as our first at bat, right? And we know that the cancers are going to be pitching us fastballs and curveballs, and you know, maybe even a spitball here and there. And so EBAT is we think part of the solution. It actually tells us that this idea works. But it does have some limitations, right? First of all, it includes a lethal bacterial toxin, which is not the easiest thing to sell, you know, to an owner. We say, you've got a healthy dog and we want to give it a lethal bacterial toxin. Some people kind of freak out. The production is challenging. I think it's a great therapeutic. I think it's a fantastic concept for prevention, but I think we are working really hard to understand what the next generation of preventatives are. And so that's part of our objective. And we have a large group at the U of M in the Animal Cancer Care and Research Program trying to understand whether the prevention should be chemical, immunological, molecular, and metabolic. So we have a lot of ideas going, like, how do we change this environment? And at the same time, we've got a couple of other projects that are looking, you know, we talked about cancer genetics being very, very much alive. So we have a project that's funded through the AKC Canine Health Foundation and 6 partner breed clubs that we call COED. And COED is essentially canine osteosarcoma early detection. And again, we're using little bits of material that cells spit out into the circulation. And you can think of these things as little packets of communication that a cell in your toe might send to talk to a cell in your nose. And, you know, they're not physically connected, but they essentially drop a little, you know, letter into the postal highway of the blood, and the letter is received on the other end, and it's read, and then it's answered. So we're actually intercepting the mail or the code. The other thing that's carried in these little vesicles is garbage. So cells are not particularly ethical in how they maintain their cleanliness, and they're driving around and they blow their nose and they throw the Kleenex out the window. And we're picking up the Kleenex that they're throwing out the window and essentially digging into the snot and the Kleenex to find out what the cells were doing. Were they healthy? Were they alive? And so we're looking at patterns of messenger RNAs, gene products in these little vesicles in the blood to, again, create diagnostics that inform for the presence of cancer or the risk of cancer. And we're specifically looking, in this case, at osteosarcoma, although we're doing this in a variety of cancers.
Yeah, it should be a platform technology, right? It should be.
It is a platform technology. We actually have a discovery platform that we created that allows us to do that for a variety of cancers, therapeutic response, transplantation. So we're applying this to osteosarcoma. We have a test that we published a couple of years ago that shows that we can detect the presence of minimal residual disease in dogs that have received treatment. So, you know, the question is, like, what can you do about it, right? So if the dog is undergoing treatment and there's no minimal residual disease, it means it's responding well to treatment, and the opportunity to continue and have a good outcome is great. And so we found that the dogs that are negative in our test for MRD tend to be long-term survivors for osteosarcoma with conventional therapy. And then the dogs that have MRD, which unfortunately represent, you know, a large proportion, tend to do worse. And so the question then is, you know, if you are looking at a $10,000 bill of chemo after you do surgery and perhaps the first chemotherapy, and you've got, you know, 3 or 4 treatments left, if there's MRD present, you might actually think about whether you know, as an oncologist, you might want to think about whether you recommend trying a different kind of chemotherapy or perhaps a clinical trial, or for some owners, hospice might be the right thing, right? So so there are multiple different applications for this test. And again, we're also trying to think about what is the intervention, right? If we can actually find risk, what are the mechanisms that are driving that risk, and how we can intervene to prevent the disease. And then our newest one, which is called LYRA, Lymphoma Risk Assessment, and that's funded by Morris Animal Foundation. And it's a really cool intersection with the Golden Retriever Lifetime Study, because we're now using bits of DNA that are floating in the blood. And so these bits of DNA come from cells that have died or have somehow extruded or spit out some DNA, and the DNA gets fragmented. And so this is used widely by a number of different companies to look for tumor DNA in the blood. You know, famously PetDx, while they were alive, they were looking for tumor DNA in the blood, and they were doing this through sequencing. And I think the technology is really powerful, but again, what we are doing that's a little bit different is we care about the tumor and we'll find it if it's there, but we're actually looking for patterns that tell us that there's this environment that is allowing the tumor to grow, or that the tumor is essentially modeling to grow, and how we can intervene in that environment. So the really cool thing that we're doing with
fragments are only one of the variables that your testing looks at.
Correct.
And it's amazing. I was looking for. Go ahead, please. Sorry.
Yeah, no. So what I was going to say that's very different is that, you know, people are gathering all of this information. They're gathering the whole alphabet, but then they're only looking at the vowels, right? And they essentially throw away the consonants, because they say we only care about the vowels because that's a tumor DNA. We basically are saying the consonants are really important, right? You can't make words with only vowels. So we want to look at the consonants as well. And if there's tumor there, we can find it. We know what to look for. But we're more interested in the stuff that's coming from all the non-tumor cells in that environment. All those DNA fragments that people are saying, oh, we don't care because they're not from the tumor. We actually care, and we're creating these patterns that tell us about the environment, because that's where we think the effective intervention is. Yes, we want to kill the tumor, but more importantly, we want to destroy the house.
Yeah, it's all data. Interesting enough, the one way to look at it, there's a lot of data there, and some of it could be historically construed as garbage, and there's that garbage in, garbage out, but it's you can't look at it that way. It's data, it's relevant data, and it's associated with the tumor genesis and tumor metastasis. But I apologize for jumping in and interrupting you, but you've covered on so many points, and you just jumped on one that I wanted to talk to you about, because going back to the hemangio, two things I wanted to discuss specifically about that. I just moved to San Antonio, one of Indiana's. The reason why identifying it is, as we know, hemangio is a silent killer. You don't know it's there until it's too late, and it's catastrophic, and you're dealing with a nightmare scenario, and typically it's far too late to really have any good clinical outcome. But I met one of Indiana's veterinarians here in San Antonio. She lost two of her dogs, Goldens, to hemangio. And you know what she told me, Dr. Modiano? She's like, now my policy is, with my new golden, as soon as my new golden turns 6, I'm doing a prophylactic splenectomy. And I'm like, wow, we've gotten, how did we get to that point where we're just taking potentially healthy, normal spleens out because we're afraid? And I wasn't critical. I didn't judge or critical. I find what people do and why, I find that very interesting and fascinating. But I'm like, that's like medieval. If we start, it's like taking tonsils out. I still think people take tonsils out, even though I think, well, nature put them in there for a reason, I think. So, yeah. So what you're working on is so hugely important. And then the second thing so we can't be going medieval. We can't be taking out organs and stuff just because we're not able to do early detection. And the second, and I think most important, powerful thing you're talking about is PetDx. We've had Dr. Andy Flory on a couple of times. We were early adopters. I think, Ginger, you and I, between our dogs, we've used 6 tests. And we only found out recently that they went under, that they're gone. And to me, I wanted to get your thoughts about that. And it seems like the diagnostic technology that you're working on is similar, but it's more robust in certain ways. And so it could produce better
I don't know that it's, I wouldn't call it more robust. I think it's just different. I think so. So the first thing is that there's nothing in the public domain. I've looked to see if there's any formal official news, and the only thing that I have seen from them is that they have told veterinarians they're not running tests. So there was an article in a network or reporters saying that they went under, but that's not formal news from the company. So I don't want to use those words. All I know is that they've said they're not running tests, and I believe they said for financial reasons. I think that when our experience in developing diagnostics is that there are some platforms that are feasible to run in a diagnostic lab at scale that make commercial sense, and there are other platforms that don't. And I think next-gen sequencing, even though the costs have come down tremendously, is still not a scalable technology that can sustainably support a company right now. And I think that's true not only in the veterinary space, but also in the human space. So I think that the answer generally, I think this might change. I had an interesting conversation with someone from Johns Hopkins, I'm sorry, from Stanford, that is actually telling me that they're finding that their next gen technology is actually less expensive than using arrays. This is for pancreatic cancer. They're doing some really fascinating stuff. But I think right now, generally speaking, technologies that are tried and true, like immunohistochemistry, PCR, arrays, that can be done at scale, and therefore the economy of scale allows you to really offer this as a platform, are probably easier and more tractable than doing next-gen seq on, large numbers of samples. I think that there were, the fact that PetDx raised $72 million in their their 2 rounds of funding was amazing. But clearly they were, spending more than they were making. And so I think the answer is not so much on whether there's a need. I think that I had some conversations with Dr. Grossu and with Dr. Flory, and we certainly have a lot of agreement, and then we had some areas of disagreement about when and how you would use the test and what the actionability was. But I think that the technology is really powerful, and I think there's definitely an appetite and an unmet need for the technology.
It's the future. It will be. It's the future. And you spoke to something about next-gen sequencing not just being easily scalable right now. And I suppose that I've only talked to Dr. Flory, never talked to the founder. But to me, it's an adoption, right? It's going to take a while, in human medicine and also veterinary medicine. Pet parents and patients are slow to adopt, right? Especially if it's expensive technology. And PetDx's OncoK9 was not cheap. But I think Ginger and I, we looked at it and we discussed it at length. And I think the other problem is you get the indication that your dog has cancer, but then you have to do all the additional diagnostics to find that cancer. So, with Ginger, you can speak about it if you want. In Sadler's case, she had to do, I don't know how many thousands of dollars, ultrasounds, chest x-rays, and it was, go ahead, Ginger, please.
It was probably a good $4,000 after the test. And we were early on. So PetDx, I want to say that they contributed like $1,000 to the additional testing. And, but yeah, he wound up having hemangiosarcoma, and it was on his heart. So.
Yeah, and I think, one of the conversations that I had with them was exactly that scenario, right? Like, what do you do? What can you offer? And so they had anecdotes about the person in their sphere who essentially was in your same situation, and she was able to really sort of enjoy the time that she had left with her dog, knowing that the dog had a terminal cancer, and it changed her outlook, and it was a very happy story, right? But I don't think that happy story necessarily applies across the board. And I do think that having a news like that, particularly where you feel powerless about doing anything to help your companion and your family member, can be very anxiety driving and can change your relationship with your dog, right? In some cases, even making you feel that the only thing that you can do is put your dog down, because you now see them as a ticking time bomb as opposed to
Right.
a companion, right?
exactly. And he wasn't really exhibiting any physical or clinical problems. The whole reason I had taken him in like a year before, and he had a tumor on his spleen. The reason I knew that is because he let me trim his nails, and he was like would never let me trim his nails before. So I immediately took him in, and we found the tumor on his spleen. We had that removed, and then I did the PET DX the next summer. And then that came back that they found, some issues there. So then it took several months to go through the other additional testing. And then by the time we got to the end of what we could test for, then he had the signs and passed away.
Yeah.
Too
So
bad your LLMs can't model for that variable.
Yeah, well, I think that there's a couple of points that I think are really interesting about this discussion. The first is the sensitivity that the technology can actually have, right? So they found something that was imperceptible to you through all of the things that you could do, and it took a lot of testing, a lot of money, and then time before you could find it. So I think it speaks to the power of the technology. But I think the downfall of the technology is also like, we had to spend all this money, and so from our perspective, imagine that we have sort of our flagship Shine On, right? So we have a dog that comes in with high risk, and so that means that the cancer could be there, and if the cancer is there, then that is a cancer patient. It could be that the cancer is not there, and that becomes a candidate for prevention. But we are still struggling with the idea of what do we need to do to distinguish between the cancer patient and the healthy dog that can receive prevention? And that's right now, our cost is a $2,500 series of tests, right? And then there's the intervention, which we pay for because it's experimental, but if and when the drug becomes commercially available, the market's going to set a price, right? And we are having discussions because we think that the price should be affordable, but that ultimately is not our decision, right? And so it may be that the solution is not really a solution at all if people can't afford to use it. So we're very, very cognizant about that. And again, thinking about maintaining the test platform, the intervention in a cost space that, it may not be accessible to 100% of pet owners, but we'd want it to be accessible not just to 1% of pet owners, right? We want it to be more widely accessible to the public. So it's something that is very much at the forefront of our thought process, which is in an academic environment, we're trying to do discovery and research and really improve our understanding, but also working with the idea that if this is a commercial application, which really is the intention of the people that are giving us money, how do we translate that to make it widely accessible? So I think, that's one thing. I think the other point that you bring up, which is really interesting, is, the veterinarian that said, or the person that said, I'm going to do a prophylactic splenectomy on my dog. We're starting to learn some really fascinating things about hemangiosarcoma in particular, and it's probably going to apply to other cancers, but hemangiosarcoma comes from cells that contribute to the formation of blood and blood vessels. And we actually know now that there are different flavors of hemangiosarcoma. So it's not just one disease. And there are different cells in the bone marrow that might actually give rise to the disease in its different manifestations. But one of the things that we infer, so we think we know, but underscore think, is that these cells exist in the bone marrow and in other blood forming organs, and they can travel from there to many parts of the body. So we think that when a dog has a transformation event in one of these cells, those cells distribute far and wide. And so they're going to be sitting around in the brain and in the heart and in the gut and in the kidney and in the spleen. And they, through things that we don't entirely understand, but that have very much of a Darwinian stochastic influence, are essentially evolving and creating these tumors in the different tissues. And so they also communicate with each other. And there is a school of thought, and I don't know if I subscribe to it or not, but there's a school of thought with some data that says that when a primary tumor is forming, it actually suppresses metastasis. And if and when you remove that tumor, metastasis can thrive. So we are pretty certain that the hemangiosarcoma cells that form the tumor in the spleen, some of those guys, long before the tumor in the spleen formed, already went to other places. And that removing a healthy spleen is not necessarily going to help because the cells are evolving in the heart and in the kidney. And so when we've looked genetically at metastatic tumors from dogs with hemangiosarcoma, and this is, very sparse data because we don't have large data sets. We have very small data sets, but we have enough data sets to see that in some dogs, the tumor that started in the spleen and the liver are twins. They're virtually identical. And so one started and then went to the other place, and the tumors were the same. But we have enough data to actually show that in other cases, the mutational profile of the cells in the spleen tumor and the heart tumor and the lung tumor and the liver tumor were different. And the behavior of the cells in those tumors was different. So we think that they had a common origin, and they all migrated from that common origin to the different places. And then they went through separate evolution. And so the hemangiosarcoma of the heart evolved in a totally different environment with a different set of mutations and metabolic needs and energy needs that the guy in the spleen. And while they're communicating with each other, one might win, the other one might lose, or both of them might grow independently. So taking out the spleen of a healthy dog because you might prevent hemangiosarcoma of the spleen is not addressing all these other issues, right? So, as you said, Luke, the spleen is not window dressing, right? It's been around evolutionarily speaking for several 100 million years, and we don't recommend taking it out just because it's not really going to help.
Go ahead, Jen.
So, Dr. Modiano, when Sadler's tumor and spleen were removed, it came back as benign. So if I understand what you're saying, there still could have been those other cancer cells, and then that's when they went to the heart. Am I correct on that?
I think the cancer cells had gone to the heart long before anything happened in the spleen. So that transformation event could have taken place when he was 3 months old, or 6 months old, or 4 years old. But they just seem to kind of sit there, and we don't really know how long they sit there, right? Part of it, they sit there because they're forming a tumor and it's insidious and we don't know, and the dog doesn't know. But part of it, we think, is that they're just kind of chilling out, slowly evolving to get the foothold that they need to do what they do. And cancer is not smart, right? It is just basically it's simple Darwinian evolution in a microscopic scale. There are selective pressures. The cells that do poorly die, and the cells that can survive thrive. And it's a constant battle because the body does not like to see disorganization or dysfunction in tissues, and so the body responds the way that it can, which is inflammation, and the inflammation creates selective pressures. And so it's this thing that's going on. So the tumor, the mass in the spleen, which was benign, is something that we see very, very commonly in older dogs, and it seems to be a dog thing. One of our Gordons actually had a splenic hematoma that freaked us out too. We had him go through surgery. It was benign, and he lived for another couple of years and died of something entirely unrelated. So it's a common thing that we've experienced. But just because there's a benign thing in the spleen doesn't mean that they're protected from something else. And so I think that in Sadler's case, you would have been looking at something that could have happened after the spleen tumor because the cells were sitting in the bone marrow, and then they decided there's no spleen, we're going to go to the heart, or they might have been sitting in the heart for weeks or months or years before you took out the spleen. And they might have been totally unrelated to the two things might have been totally unrelated, or they might have been that the cells in the spleen decided they didn't want to be so bad, right? And they created this environment that bleeds but doesn't become malignant, and the cells in the heart were a different piece.
Okay.
You said something really fascinating, and I want to speak to it. I'm fascinated by evolutionary biology. and evolutionary genetics. And you said there's a school of thought that thinks that the primary tumor tries to prevent metastasis. And I thought, well, why would that be the case? And if you think about it, well, once it metastasizes, and it's almost always the secondary tumor site that it ends up causing the fatal damage, right? Causing the fatal problems. So I guess you're right. If the original cancer tumor cells want to survive from an evolutionary standpoint, they don't want it to metastasize, right? Because the other thing you're going to do is you're going to kill the host organism, right? It's the parasitic sort of model. The parasite never kills the host, because if it kills the host, it can't do what it wants to do or achieve the outcome that it wants to achieve. Is that?
The short answer is that makes sense, right? But it's very teleological. As I said, cancer is not smart. It's not planning ahead. So the idea that primary sites repress growth, they don't repress metastasis, but they repress growth of metastatic sites, originally comes from observations that Judah Folkman made. And you might know Judah Folkman as the father of tumor angiogenesis. So Judah Folkman was a surgeon, and he was very frustrated because as a surgeon, he would take out tumors, and he thought that he had cured the patient only to see them die of metastasis. And so he came up with the idea of angiogenesis because he would take out tumors and they were red and angry, and he said they're full of blood. And that's what gave rise to angiogenesis. And so he started thinking maybe the primary tumor that is highly angiogenic is suppressing angiogenesis in the distant tumors. And so he discovered endostatin and angiostatin. And the idea was, the primary tumor is making these things. It's preventing angiogenesis or blood vessel formation in the distant tumors. And that's how it keeps them at bay. So this is the cure, right? And so in the late 90s and early 2000s, there was a big drive to do anti-angiogenics. And you might remember all sorts of stuff in the dog world. There was a Navy protocol, which completely different story. If anybody wants to try it, it doesn't really work. But the idea was to prevent angiogenesis. And it turns out that endostatin and angiostatin are really important. But the idea that is the way that primary tumors prevent metastatic growth has not panned out. There's other things that are going on, but the phenomenon that Folkman observed seems to be true. Other people have observed that when you have a primary tumor, there is repression of metastasis. And when you take out that tumor surgically or you radiate it or whatever, in many cases, not in every case, in many cases, the metastatic tumor growth just goes explosive. And the question is why? Why is it, right? Why does removing the primary tumor allow the other guys to grow? And we don't have the answers. We know a number of things that it's not, but we don't know what it is. So I think the idea that, the difference between hemangiosarcoma and other tumors in terms of metastasis is that the conventional metastasis is that the primary tumor starts somewhere and then it seeds metastatic sites from that tumor elsewhere. In hemangiosarcoma, we think that the malignant cell spreads well before a tumor is formed, so that you don't need that sort of invasive leading edge, going into the bloodstream, colonizing. We think that these cells, based on their nature and what they do, they can go anywhere they want. Just when you think of a white blood cell, the white blood cell has access to any part of the body. And we think these cells, just like white blood cells, have access to anywhere where they want to go. And so they disseminate because that's what they do. And they have the potential to form a tumor, but not all of them do. It's really interesting that people think of hemangiosarcoma as being a disease of golden retrievers or German shepherds, but it's a disease of all dogs. And yes, there might be some breed differences, but there was just a paper that came out 2 weeks ago, collection of 8 African wild dogs in a Japanese zoo. 2 of the 8 adults developed cancer. One was a female that developed mammary cancer, and the other one was a male that developed hemangiosarcoma. We've seen that in wolves at the Wolf Center, that the wolves that live 8 or 10 years are at greater risk of tumors like lymphoma and hemangiosarcoma. So this is not, it's a dog thing, and so we think that there are things about how well, first of all, we've expanded canine lifespans by 4 times, right? We talked about that the last time. So simply the fact that they're living longer than their evolutionarily adapted lifespan puts them at grave risk of chronic diseases of aging, including cancer. But beyond that, we think that there's something very peculiar about how the canine vascular system evolved. So having a particular network of blood vessels where they feed their tissues was advantageous to primordial dogs. And that evolutionary adaptation exists across the dog world. And we think that there's something really peculiar about how these blood vessels form, grow, and remodel that makes canids, so the broader scope, vulnerable to hemangiosarcoma, which is not something that we see in other animals, even that are kept in zoo collections and, outlive their time. So there was an article that just came out yesterday saying that in humans, angiosarcoma has increased in incidence between 2000 and 2020. And they said in humans, it used to happen in one human out of 1 million in 2000, and now it happens in 2 humans out of 1 million. So that's a doubling, right? But you're still talking about 2 humans out of 1 million, whereas in dogs, hemangiosarcoma is far, far more common.
One of the top three cancers in yeah, dogs.
It's certainly more than 2 in 1 million. So right. So again, we think that, and because we see it, we see hemangiosarcoma in other species really, really rarely. But it's obviously reported in other canids, and it looks the same. It looks exactly the same as it would in your standard poodle or your Pomeranian or your golden retriever. So we think that this is something that harkens back to how dog blood vessels form, the cells that contribute to that blood vessel formation, and then added on that you live long enough to get the cancer. So I think I told you the last time, the youngest dog that I ever diagnosed personally as a pathologist was a 9-week-old puppy that had hemangiosarcoma of the brain. It's tragic, but that's only one, right? If you ask me, like, what's the average age of dogs that you see with hemangiosarcoma, it's 10. So this is a disease of old dogs. Any dog can get it, but it's a disease of old dogs. So if you live long enough, you don't die of something else, and you're a dog, your risk of hemangiosarcoma is pretty high, and it's true for other tumors. So, what our breeding has done to modulate that risk is a really interesting question, but it is not a disease of German Shepherds and Golden Retrievers. It's a disease of dogs,
right,
where there might be some slight breed differences. And like other tumors, we do see it more in bigger dogs, but we see it in tiny dogs. We've had some dogs in our clinical trials that weighed, 4 pounds. So.
But as you know, one of the I guess I think the most frightening aspects of hemangio is without early detection of the disease or even a biopsy, which a lot of pet parents don't do. I can't recall the percentage, Ginger. I think 40% of all dogs that are euthanized with suspected hemangiosarcoma don't actually have the cancerous type. They have hemangio. It's a huge number.
Yeah.
And so, that's why hearing the news about PetDX, it really, to me, it was just earth shattering, because we have to have a tool out there. I'm a dog dad. I need tools out there, and I need the best available tools that we can get that are reliable. I don't mind paying for the additional, ultrasound or CT or this or chest X-ray or this or that to a certain extent. But there's a demand out there for it, and so it's just a function. I like how you talked about commercializing diagnostics or any technology. It's a reality, right? You have to at some point downstream, you have to make money. It has to be paid for, and that's just part of the commercialization process. But from my perspective,
I apologize for the interruption, but I think I just wanted to do a shout out to my colleagues at Ethos who are doing the push trial, right? And so they're trying all sorts of different combinations. We are part of that. So Dr. Borgatti at our institution is actually part of the push trial. But I think the really cool thing that they've done is they've amplified exactly the idea that you said, which is that half of the dogs that have a splenic mass and might be euthanized because of that mass not being biopsied are dogs that have a curable condition, right? Of course, curable means that you have to have a competent surgeon. You have to have the money to pay for the surgery. There's all of these factors, right? But the dogs do not have hemangiosarcoma, and there's just an assumption. And so, you know, whether it's 40% of the dogs with splenic masses or 60% of the dogs with splenic masses, I mean, we've known that the original paper that described that in a large number of dogs was a paper by Dr. Spangler from IDEXX back in 1992. So we've known now for 30 years, right, that half of the splenic masses are going to be benign. And yet, you're right that, you know, either because of ignorance or circumstances, a lot of dogs with a splenic mass are euthanized because it is called hemangiosarcoma when it's not. So it is a struggle to get the right information out there. And honestly, I'm really happy that you guys do this podcast that reaches, you know, pet parents, because there's a lot of misinformation in social media. You know, some of it purposeful and malicious, and some of it just inadvertent or because people don't know any better. But there's a lot of stuff that's being put out there that, you know, you need to use this supplement or buy this food or whatever because, you know, it will protect your dog. And there's just a lot of bad information out there that is not professionally vetted. So I'm really grateful that you guys are doing this to reach people and at least have a different point of view, right? So hopefully before they spend $2,000 on that supplement, they will think about whether it's really worth it and whether the information they're getting is correct.
That's right. Well,
I'm
Right,
going
please.
to interrupt here. So speaking of the pet DX, a friend of mine, we have the same veterinarian, and after my veterinarian's experience with Sadler, with it coming up benign and then actually coming back with cancer. So my friend's dog was tested. I can't remember. It might have been a splenic tumor, but it came back benign. And they sent it for more testing and it came back benign. So they discussed it and they did the PET DX just to make sure that it wasn't. And so I thought that was pretty interesting. And then the other thing that Luke and I had talked about after hearing about PET DX was I understand that you need to market to veterinarians, but there should be some type of marketing to the pet parents, because I think, like for me, I drove the PET DX testing to my vet, then they use it for other because they hadn't heard about it. Their representative from IDEXX or Antec, I can't remember which one, hadn't even mentioned the PET DX testing to them for them to be able to offer it. So how do you see that in the future? If you see that in the future, because I've been told, well, that's way too expensive, but I think there are relatively inexpensive ways to do that besides our podcast.
Yeah, that's a really good question. And I think that direct to consumer marketing works. And all you have to do is turn on your television if you happen to be of an age where you still watch television, right?
Yeah.
But even if you don't, I don't do Facebook, but I am sure that Facebook is flooded with ads from pharmaceutical companies saying, talk to your doctor about. So the reason that we see so many ads, and I'm young enough or old enough to remember when drug ads were deregulated, right? So it used to be when I was a kid that pharma companies could not advertise to consumers. They were not allowed to advertise in newspapers or TV or radio. Interestingly, cigarette companies were allowed to do that at the time, but pharma companies were not. Now it's a reverse, right? So it really works. And in our strategy, so the University of Minnesota has what they call the Discovery Launchpad, which is the incubator for startups. And we've been in a stealth mode in a startup for a long time. And again, full disclosure, right? This technology, if it has legs, might actually come out of a startup. But we've had the discussion about what is the right strategy in terms of advertising to veterinarians, direct to consumer. I think that there's a lot of different answers and different approaches, and each one of them might work differently depending on what it is that you want to accomplish. So I'll give you a little hint of the things that we deal with. Let's say, for the sake of argument, that our test is going to move to commercial space. And to be very clear, it is not yet. Okay, so it's not ready, but let's just argue that it's ready. And let's argue that we can price that test to the consumer at $300 to make a round number. So that means that the vets pay less and they have a markup, right? So we go, okay, so there's a number of tests that we have to run in order to reach break even or profitability. So we have to go and be able to sell this to investors. So what's the market? Well, the idea is that there are 90 million dogs in the United States living as companions in homes, right? And let's say that only half of them are over the age of 5. So that's 45 million dogs. That would be your addressable market. So the question is, how many tests can you run in a day? So if you had 45 million people who wanted to test their dog, what would you do? And the answer is you would implode. There's no way that we could run 45 million tests. So I think that the question is, how do you identify the right population to market to that is going to actually do two things? One is, from my perspective as a veterinarian, help the largest number of dogs at risk live healthier lives. That's what I think of as a veterinarian. The people who are my business partners say, what is the population that we should address to achieve profitability? And then what is the intersection of those two that you should go after? So, when we think about a test being out there or being available or being developed, or why aren't you doing this? The challenge is, how deliberate are you in studying the science, the medicine, and the business, and trying to put all those together so that you can actually thrive and survive and benefit society. I think that if those of us who are veterinarians were looking for a quick buck, we would be doing something else, right? So we are not necessarily motivated by profit. And I think we are motivated by the anxiety that we see. And people say, well, this is great that you might be helping dogs in the future, but what about my dog? So to help the dogs of the present, we are trying to push the envelope with clinical trials of things that we know how to do right now. So, whether it's drugs that we know and we're trying to repurpose them, or drugs that we have, or ideas, we're trying to essentially tackle the cancer population of today and improve their outcomes by doing things that we can do in the short term, with really the long vision of basically saying, we want to promote graceful aging and reduce cancer risk at the same time as reduce risk for other chronic diseases of aging, so that we're all going to die, right? Death and taxes, but we want to be able to reach that point, having fulfilled our hopes and our dreams, and having provided our dogs with the longest, healthiest health span that we can. So I think that those are, they're very challenging questions, but they're the reasons why we get up in the morning. Because we could very easily roll over and say this is too complicated, and
we should really do an entire episode on the business of drug discovery, drug development, and building a veterinary company. The good news is that everything follows sort of alongside Silicon Valley and how they scale high tech over there, and biotech in the human medicine world. And so I just noticed at conferences, you're starting to see a lot more VCs, a lot more angel investors, veterinary groups that are angel investors. And then now you see all the supporting consultancies and stuff to help commercialize it, right? Because the skill sets that make you a very able, competent scientist are not necessarily the same for you to understand the psychographics and demographics of your target market, or or quantifying a value proposition. But the big piece that I think is missing in all this is, when are insurance companies going to step up and start covering these? Because again, we're looking at catastrophic situations that are very expensive if they're not detected or discovered early. And I don't really, that's a beast of a different sort. They don't really do that in human medicine, insurers very well or effectively either. But it's an important piece of the puzzle.
Yeah.
We're running a little bit long, and my apologies. I know you're so busy, Jaime, and I appreciate you. Every time we're going to have you on every year. I still
You
have.
should do it twice a year. We should do it twice a year.
That's presumptuous. I don't want to be that presumptuous with your time, but I still have so much to talk to you about. But every time you mention something, it's just it's another area that I want to explore. But I did, before I forget about it, Ethos, is Kana still involved with Ethos? Is he still involved with that group?
So I will tell you what I know, with full acknowledgement that I only talk to Chand every so often, and I'm not exactly sure what he's doing. But the last thing he told me is that he is formally retired, but he is still working as president of Ethos Discovery, which is the nonprofit arm, and heavily involved in the ideas that Ethos Discovery is trying to do to really advance veterinary medicine. But now he does it because he wants to, or not because he has to, I think, I think Chand is a phenomenal person, a fantastic scientist, a great veterinarian, and has been really a spark plug in the engine of the modern evolution of veterinary oncology. So we have a lot of gratitude for him. He's a fantastic guy. And, I think that I don't think the Pet DX story is done. I don't know what they're going to do. Hopefully they are able to reorganize and emerge stronger, maybe the same, maybe different. But you're right. I think that this is, it's the genie side of the bottle, right? So people have these expectations, and I think how we manage them, whether it's through third-party payment or something else. I mean, the challenge that we have is that people expect us to deliver the quality of medicine for their companions as they get themselves. And the difference is that if you go to the ER and you're uninsured, they are obligated to take care of you, right? At least, and this is a crisis. But if your pet has a catastrophic illness and you don't have the money to pay for it, nobody's obligated to help you out. And so there's a lot of options that we try to put in front of people, but they don't always work. So the economics of this modern, technologically driven veterinary medicine world are very, very different than when I started vet school in 1984. And we talked about it then, but it's a different beast now. And I think we really need experts in economics to really address this issue, because it's not simple. And I agree with you. I think third-party payers don't do it very well in the human market. I know both of our pets are insured,
right?
And I think all we're doing is we're paying up front what they're going to give us on the back end.
Correct.
So I'm not sure how they're making money.
You're so right. You said it profoundly and perfectly, that the economic, I mean, everything evolves over time. That's just the nature of things, and the industry is evolving. We are going to do direct to consumer marketing at some point. So anytime you want to talk about whatever you're working on, Dr. Modiano, you're more than welcome to come back here on Fuzzybutts and Friends, because our objective is to get good quality data to the pet parents to make the best decisions that they can for the medical benefit of their Fuzzybutts. And so that's really what I see as our platform, the purpose of our platform. But we want to have you back on for sure. Fortunately, I met John early on. My first walk from across country, I met him when I walked through the Virginia, D.C. area. And he provided sort of the framework from which the lens. I think he gave me a good lens from which I view cancer in companion animals. And yeah, Ginger, we were talking about getting him on the show, but also would like to get Dr. Borgatti. Is that correct, on the show, do you think? Have an interest?
I think it would be wonderful. She is brilliant and charismatic and just an amazing person. And I think that you would really enjoy having her, and her Italian accent makes everything just so much better. So
well,
I think
I hope I don't offend her by and mess up her name, though, because I know I like to say yours Modiano, but I do so because I love it. I love the language. It's so passionate, la passion. It's just a wonderful language. But all right, Dr. Modiano, Jaime, did I miss anything? We've run long. My apologies. Ginger said, don't waste too much of his time, and I'm like, well, I'll try not to, but I just love talking to it.
You know, this has been really fun, and fortunately for you, my 11 o'clock canceled last night because she had a sick child. So we had freedom to operate. I did not have to run off to something else, so that was helpful. I do want to apologize for Alcy and Maura having a little bit of a bark fest in the middle of our podcast, but thank you for allowing me to be on and talking about what we do. It's you know, you can tell that we're excited about it. This is not me. It's I'm part of a team. You know, I get to do the talking, but they get to do all the work. So I do want to acknowledge that the work that we do here is only possible because we have a fantastic team and support from the Masonic Cancer Center and the vet school. And it's been just, you know, it's been a great ride. So I appreciate you guys, you know, getting the information out, and yeah, we'd love to be back on with you.
Yeah, I'm actually. I was talking to Ginger about it. When is the next VCS going to be in Minnesota or somewhere nearby?
Next year.
Is it going to be next year?
Yeah, I think it's either 25 or 26 because we're already starting to plan with Cindy. So
Okay.
as you know, Sandy Strother is retiring this year,
Yeah.
and
Oh, I did not know that.
yeah, we have her goodbye party all planned, and actually, I shouldn't say that in public because I don't know that she knows. But anyway, Sandy does know that she's retiring, and this will be her last VCS. Got moved from Daytona Beach to Orlando, I think, and then it's either next year or the year after it's going to be back in the Twin Cities. So we'd love to have you guys visit, and
Absolutely.
you know, maybe we can actually show you our digs in person.
And maybe we
that
can do
would
a
be fantastic.
live show from your lab. That would be
Live
wonderful.
show, that would be, well, yeah, I don't know if the lab people would enjoy that, but we can, you know, everything can be solved with some nice treats. So, you know.
Yeah.
That's true. All right,
Yeah.
Jaime. Well, thank you so much for all your time. I'm grateful for it, and for all the contributions that you make to veterinary medicine. And I'm very excited about the projects you're working on, and I look forward to learning more about those. All right, Ginger. We reached that time of the show. I'd say normally we have a puppy up cancer tip of the week, but we've been talking about cancer
The whole time, right?
We have lots of tips for our audience. This is, to me, it's such a powerful episode. We talked so much about the I guess the evil entity that is cancer and the sophistication of it. It's just that's its evolutionary nature. And because I still meet so many people on the road and on my travels, Ginger, that think as cancer is a static quantity. And it couldn't be further from the truth. So I hope everybody enjoyed this episode. I want to thank you, Dr. Jaime Modiano, with University of Minnesota and Modiano Labs. I hope to visit very soon. Ginger, did I screw anything else up or get anything wrong this time? I'm sure I did.
Let me think. No, I don't think so.
All right. Well, I'm sure if I did, everyone will forgive me because just out of my passion and curiosity of everything. And we'll see you next week. You can check out this podcast episode on our YouTube channel. That's fuzzybuttsstudios.com. Or you can listen to it via audio on your podcast platforms, such as iHeartRadio and Spotify. Until next week, everyone, puppy up. Talk soon.
Bye.
Thank you so much for having us.
Hang on,
Thank
Dr.
you.
Modiano.
Yeah.
Bye-bye,
Take
everybody.
care.